That was called the ice-free corridor hypothesis, but it's been made more and more untenable by finding these super old sites.
They were supposed to walk across a frozen bridge from Siberia, hunters wrapped in furs, chasing mammoths into a new world. But deep beneath the silt of a vanished Canadian lake, scientists have uncovered something that doesn't fit that story. A trail of DNA, not from bones or tools, but from the earth itself, reveals that when the doorway into America finally opened, it was already too late. Because humans were here thousands of years earlier, in places no one could have possibly reached on foot. So, if the land was sealed by ice, how did the first Americans get in? For more than a century, textbooks told a simple story. The first Americans crossed from Siberia over a land bridge called Beringia, then journeyed south through an ice-free corridor between two colossal glaciers. But over the last decade, that tale has begun to collapse, not through speculation, but through DNA. From footprints frozen in ancient mud to genetic traces hidden in lake beds, a wave of discoveries between 2022 and 2024 has revealed a far older, stranger, and more daring migration. What these new genetic clues show is that the first Americans may not have walked into the continent at all. They may have sailed. Before we dive into this revelation, make sure you subscribe to Root and Relic, where we uncover the forgotten migrations, genetic mysteries, and lost civilizations that shaped the story of us. It began with a simple map, one that showed a vast land called Beringia, connecting Siberia to Alaska. 20,000 years ago, sea levels were about 120 meters lower than today, exposing a grassland larger than modern India. For decades, archaeologists believed this was humanity's gateway to a new world. They called it the Clovis-first model. Around 13,000 years ago, a culture of expert hunters armed with finely fluted spear points, the Clovis points, swept across North America, leaving their tools scattered from Montana to Mexico. It fit neatly. The land bridge opens, people cross, civilizations begin. But science rarely stays neat for long. In the last 2 decades, discoveries have shattered that timeline. At Bluefish Caves in the Yukon, butchered animal bones reveal human activity dating to 24,000 years ago. In New Mexico's White Sands, fossilized footprints have been dated to nearly 23,000 years ago, pressed into mud when mammoths still roamed nearby. And far to the south, at Monteverde, in Chile, remnants of wooden huts and plants show people living there 14,500 years ago, long before the ice corridor even existed. If humans were already thriving thousands of miles south, the old theory collapses, because between them and Alaska stood an unbroken wall of ice, more than 2 kilometers thick. So if not through the land bridge, how did they arrive? To answer that, scientists turn to the so-called ice-free corridor, the narrow strip that once divided the Laurentide and Cordilleran ice sheets. For generations, textbooks claimed it opened early enough for humans to pass. But in 2022, a groundbreaking nature study by Pedersen et al. Drilled deep into the sediments of what was once Glacial Lake Peace in modern British Columbia and Alberta, and discovered the corridor's secret. Layer by layer, those sediments preserved traces of environmental DNA, or eDNA, genetic fragments from plants, animals, and microbes trapped in clay over millennia. What they found rewrote the map of early America. 15,000 years ago, the corridor began to open physically, but it remained a frozen desert. For nearly 2,400 years, there was no life, no soil, no plants, no animals, nothing to hunt or burn. Only by 12,600 years ago do the first signs of life appear. Hardy sagebrush, followed by bison, jackrabbits, and the last woolly mammoths. In other words, the route only became biologically viable after humans were already living deep inside the continent. If the corridor was lifeless until 12,600 years ago, then it couldn't have carried the first Americans. The doorway north was still locked in ice while people were lighting fires in Chile. So the mystery grew colder. and the search for an alternative path turned toward the sea. Before we move on, imagine standing at the edge of a continent sealed by glaciers. Would you wait centuries for the ice to melt, or risk the unknown ocean? Tell me in the comments, because the people who founded the Americas made that impossible choice. While glaciers sealed Canada beneath kilometers of ice, the Pacific coast told a different story. As the sea retreated, a chain of rocky headlands and islands emerged. A narrow lifeline stretching from Japan to Alaska and all the way down to California. This became what scientists now call the Kelp Highway, a ribbon of rich marine ecosystems, where humans could sail, fish, and survive long before the interior thawed. These kelp forests were more than scenery. They offered fish, shellfish, seaweed, seals and seabirds, a renewable food web that guided early voyagers southward. Instead of trudging through frozen wastelands, they could island hop, moving along ice-free refuges with access to fresh water and abundant game. Archaeology is finally catching up to genetics. At Triquet Island in British Columbia, traces of a coastal settlement date back 14,000 years. On the Channel Islands of California, barbed fish hooks and sea mammal bones show maritime life between 13,000 and 15,000 years ago. In an on-your-knees cave, Alaska, the remains of an early sailor carried mitochondrial haplogroup D4H3A, the same lineage found in ancient South American genomes, proving a continuous coastal migration. This route stretched more than 15,000 kilometers, open while the interior lay dead beneath ice. But the true breakthrough came not from where they traveled, but who they were, and what their DNA still whispers from the graves of time. Every generation carries a map written in blood, and the genomes of early Americans have now begun to read aloud. In 2014, scientists sequenced the genome of the Anzac 1 child from Montana, buried with Clovis-style tools 12,600 years ago. His DNA linked directly to all modern indigenous peoples of the Americas, proving that even Clovis culture descended from much earlier ancestors. Then came the Upward Sun River infants in Alaska, dating to 11,500 years ago. Their genome revealed an entirely separate branch, the ancient Beringians, a population isolated in the Beringia region for nearly 10,000 years before spreading south. According to Reich et al., 2021, published in Cell, the ancestors of all Native Americans diverged from East Asians around 23,000 years ago. They remained trapped in Beringia during the height of the Ice Age, and only later split into northern and southern lineages. Mitochondrial haplogroups A, B, C, D, and X2A trace that migration like genetic breadcrumbs. From the Alaskan tundra to Patagonia, their continuity tells one unbroken story. A single founding population carried across frozen seas, surviving isolation, extinction, and the end of the world itself. Each genome adds another line to the human epic, proof that the first Americans were not wanderers stumbling south, but explorers mastering coastlines when the rest of the planet was still locked in ice. Just as the first coastal voyagers settled new shores, the planet changed again. Around 12,900 years ago, Earth plunged into the younger Dryas, a sudden cold snap that dropped global temperatures by as much as 4 degrees Celsius in a single generation. Glaciers surged, ecosystems collapsed, and many of the great megafauna, the mammoths, giant sloths, and saber-toothed cats, vanished. For the coastal settlers, survival meant adaptation. They turned to the ocean, its fish, seals, and kelp forests, while the interior froze. But when the ice finally melted, it brought a different catastrophe. The sea itself rose by nearly 120 meters, drowning most of the prehistoric coastline that once linked Asia and the Americas. Entire landscapes vanished beneath the Pacific. Archaeologists now suspect that the earliest campsites, tools, and even villages of the first Americans may lie beneath hundreds of meters of water off the continental shelf. Recent sonar mapping off Haida Gwaii and southeast Alaska has already revealed submerged river valleys and terraces that could hide those lost settlements. The trail of the first Americans may not end in the mountains or the desert. It may continue under the waves. For decades, alternative theories tried to explain the anomalies. The Solitrean hypothesis claimed Ice Age Europeans crossed the Atlantic. Genetic data has since disproved it. Other models proposed multiple migration waves, and recent genomic studies suggest that may, in part, be true. A 2024 Nature Genetics study uncovered traces of an ancient Australasian-related Y signal in the DNA of some Amazonian populations, hinting that the Americas were peopled by more than one founding group. These lineages likely met, mingled, and evolved together, shaping the rich diversity of indigenous peoples we know today. The next frontier lies in technology. Scientists are now sequencing sedimentary DNA from submerged coastlines and using AI-driven genome reconstruction to model migrations older than 25,000 years. Each discovery pulls another thread from the frozen tapestry of the past, revealing that the story of the first Americans is still being written, base pair by base pair. The ice-free corridor wasn't a gateway. It was a locked door, a dead end sealed in ice while humanity found another way. The real pioneers didn't wait for glaciers to part. They faced the unknown ocean, trusting the rhythm of tides and stars to carry them to a continent no one had ever seen. They were sailors, storytellers, survivors, and their courage reshaped an entire hemisphere. Today, as scientists recover fragments of DNA from mud, ice, and seafloor, we're beginning to hear those voices again. Ancient genomes whispering that our species' greatest journey didn't start with a road, but with a shoreline. If this voyage through time changed the way you see our origins, tap like, share this story, and subscribe to Root and Relic, where every genome tells a legend waiting to be rediscovered.